Today's objective is to be able to figure out the surface area of any shape. By the end of this lesson, you will be able to calculate the surface area of any given polyhedron. You're going to do that by learning how to count all the faces. You already know how to do the area of a rectangle or the area of a triangle. Now I want you to do all the areas and add them all up. So take a look at this shape in front of you. What do you notice about it? And I'm sure there's things that you notice about what you see, but I want you to notice things that are not here. This is in fact a two-dimensional representation of a three-dimensional thing. This is actually a box. So where's the back side of that box? How many corners are not seen? This is exactly what makes this part of geometry so hard, is that you have to imagine things that you can't see, but you know that are there. When you look at these nets, I want you to notice a few things. Take a minute to notice where the squares are. Now I want you to look again at the triangular faces attached to those squares. How are the triangles attached to each square? So I want you to take those nets and fold them in your mind and try to make a pyramid. So let's look. How many triangular faces on each net? Can each of these fold and make a pyramid? And now, triangular prisms are kind of difficult. Let's look at some rectangular prisms instead. Rectangular prisms are only made of rectangles, and so that does make it a little easier. So look at these nets. These nets are all going to make a cube. I guess you could call it a square prism, but most people just say cube. Some people will say dice. All of these can fold to make a cube, but they all fold up in different ways. Imagining how they fold is actually really hard. I know a cube has 6 faces and 6 squares, but now I have to have 6 things that move and fold in my mind. Now these nets all have numbers on them, so now I can actually calculate the surface area, and that's what we're going to get into. Before we start calculating the area, let me just ask you something. Which nets would build the most spacious bedroom? If I look at A, and that's 3 feet tall by 2 feet tall, well, I'm 5 feet tall, so my head's going to bump on the ceiling. That's not a very good one. If I look at B, well, one is 6 feet by 3 feet, maybe. If that's 6 feet long, but only, well, if I'm going to have to roll this over in my mind to see how tall the ceiling is. I think on B, the ceiling would be only 1 foot tall. I don't think I could even crawl in that room. Oh wait, but if I rotate it, maybe it's 6 feet tall and 3 feet wide. In which case I think B would be kind of skinny. Can you pause the video for a second and think about if you folded it, which one would be a bedroom? You might have to turn it around in your head. Maybe you're going to ask yourself, which one would take the most wood to build? But let's get on with the exact surface area of B and C. On A, the first thing I know is that there's 6 different faces. 2 of them are squares and the rest are rectangles. The first face is 3 by 3. That one right there. The second face is 2 by 3. Which one is 2 by 3? This one. The base is 2 and the height is 3. The third face is 3 by 3. Well, that's kind of the same as the first one, isn't it? And that one's right here. I know if I fold them over, these two would be parallel to each other. And the fourth face is 2 by 3, which is this one. And then I have a top and a bottom. The top face is a 3 by 2, and the bottom face is a 2 by 3. So I have done all the areas of all the faces, but I'm not done yet. I have to do the last step. I need to calculate the entire surface area. So that means I add 9 plus 6 plus 9 plus 6 plus 6 plus 6. And that gives me 42. Let me break that down for you a little differently on B. On B, there are 6 faces. This bottom face has a base of 1 and a height of 3. So 3 times 1 is, so the area of that face is, now let's look at this face. On this face, the base is 3 and the height is 6. So 3 times 6 is, so the area of that face is, and finally let's look at this one, this long skinny rectangle here. This one has a base of 6, but it's 6 units tall. So 6 times 1 is, and that one's 6. So I've already done 3 faces, but there are 3 faces left. So I need to do this one. It has a base of 3 and a height of 6. So 6 times 3 is, so that one's 18. So this one here, this has a base of 1 and a height of 6. So 6 times 1 is, and the area of that face is 6. And finally, I need to do this last one here. So that means the base is 1 and the height is 3. So that means 3 times 1 is, so the area is 3. That was a lot of numbers. I hope you kept them all straight. So in summary, this is what we did. We did 6 times 3 is 18. 6 times 1 is 6. 6 times 3 here is 18. 6 times 1 here is 6. 3 times 1 here is 3. And 3 times 1 here is 3. So I add all those areas up together, and I get 54. So I can say the surface area of B is 54. So let me say that again. Figure out the area of each face and then add them all up. C is going to be a whole lot easier. On C, all of the faces are the same, aren't they? Look closely at C. The base and the height is 3. So 3 times 3, this one's 9, this one's 9, this one's 9, this one's 9, this one right here is 9, and that one's 9. So 9 plus 9 plus 9 plus 9 plus 9 plus 9, well, that's 54 also. Let's take a look at this one here. Let's look at this net. I have to imagine how it folds up. I have to figure out what kind of polyhedron this is going to make. This one is going to be a triangular prism. It's going to have 2 triangular faces, and there's going to be some rectangular faces. There's going to be 3 rectangular faces. Now, if I turn it sideways, that kind of helps me imagine better. I gotta think, which one is it going to fold up to be? Okay, this is pretty hard. I'm gonna have to fold it up in my mind and see how the numbers land. Let me try just by looking at one face. Okay, so let me try this one here, 6 times 5. Here's 6 times 5. Here's 6 times 5. But 6 here doesn't match with 5. Let me see the face of 10 and 5. So this one's base is 10 and the height's 5. Here's 10 times 5. But this has a 10 times 6. I think you're going to have to pause the video here to see if you can figure out which prisms match this net. So now I can calculate the area of each face. So I find the base and height and I multiply them. And then I find the base and height here and I multiply them. And then I find the base and height here and I multiply them. Except on the triangles, I can't just multiply the base and height. The area of a triangle is half the base and height. So here's the base and here's the height. And this 10 on the hypotenuse is just a trick. You don't need this 10 here at all. So I multiply this base and this height, and I divide that answer by 2. A triangle is only half the base and height. So that's 20, and that one's 20. So now I have all the areas of all the faces, and now I just add them up to get the total surface area. And that gives me a grand total of 160. Therefore, the surface area of this triangular prism is 160 units squared. In the beginning of this video, I told you that I would teach you how to solve for the surface area of any shape. When you need the area of a rectangle, you do area equals base times height. When you solve for the area of a triangle, you can do the area equals base times height divided by 2. Using those shapes, if you can find those faces on any polyhedron, then you can figure out the surface area of it. So here's a bunch of polyhedron, and let's see if we can do it. Take a look at all of these polyhedron. I think that A is going to be the easiest. It's a simple rectangular prism, and all the numbers are easy to multiply. If I take a look at C, it's the same concept, but I really don't want to multiply anything by 13. Does F look hard to you? I see the base and the height are labeled on one triangle, but I don't know the heights of the other triangles. I think H and I are going to be the hardest. I have to do the base and the height of triangles and rectangles on the same problem. These look really hard. Can you do them? Can you draw the nets that go with H and I? We're going to be solving some of these in the next video. In this video, I wanted to show you how to calculate the surface area of any given polyhedron, but I only did rectangular prisms and triangular prisms. But I think you're clever enough to figure out most any polyhedron if it's made up of triangular prisms and rectangular prisms. By the end of this lesson, you're going to be able to calculate the surface area of any given polyhedron that's made up of rectangles and triangles. I bet you could do this one. I bet you could do this one. The question is, are you clever enough to do this one? I guess we'll find out next video.